Okay. Welcome to Reautomated the Podcast, Episode 1, Positive Sum Automation. Today, I'm joined by Ben Armstrong, Executive Director of the Industrial Performance Center at MIT, and Julie Shah, Faculty Director of the Work of the Future Initiative at MIT. Thank you for joining me.
Thank you.
Thank you for having us.
I'm sure you guys have a couple more titles there, but I just wanted to keep the succinct one. So can we start by just, Ben, can you explain a little bit more what your title is and what else you do?
So thanks for having us, Chris. I lead the Industrial Performance Center at MIT, where I'm also a research scientist focused on automation in the labor market. And with Julie, I do research on robot adoption and the implications for workers.
Very good. That sounds interesting. Thank you. And Julie, do you want to expand on your role?
Sure, yeah. So I'm a professor in the Department of Aeronautics and Astronautics at MIT, and I lead a robotics lab as a part of the Computer Science and Artificial Intelligence Laboratory. And I specialize in developing AI and intelligent robots and machines that are capable of collaborating with people, where the vision or the goal is to be intentional about developing computing and robots that are able to enhance rather than replace human capability.
Very cool. Thank you. And I believe you guys both co-authored a journal article recently in the Harvard Business Review, Smarter Strategy for Using Robots. We'll come back to that later. There's some really cool stuff in it. But let's just start by a simple question. How did you discover your passion for robotics? And let's start with Julie on that.
Yeah, so my passion way back didn't start with robots specifically, but it started with space and space exploration. I was the kid that wanted to be an astronaut. And I think I looked up at some point, there was a book of where all the astronauts in the world ever got their degrees from. And a very large portion of them came from MIT. And so at a young age, I was like, well, that sounds like a good place to go. And then I remember when I came to MIT and I started majoring in aerospace, I was very surprised because I thought aerospace was extremely highly specialized. And it turns out it's a systems discipline. And so you need to specialize further. And I really enjoyed the courses in controls and control theory, the development of autopilots, and specifically how you have to design those systems to sort of fit against the capabilities of a pilot. It's not about developing an autopilot that replaces the pilot, but how you can optimize this human-machine system. For my PhD, I moved into artificial intelligence planning and scheduling, thinking about autonomy at the task level, and became equally interested at how you sort of develop and fit these capabilities against human capabilities. And it's really at that point that I fell in love with robots, and have sort of spent my career developing new technologies that are able to enhance experts, so fighter pilots, nurses, and doctors performing like very, very challenging cognitive and physical tasks. And I've also spent many years developing and deploying collaborative robots that work alongside people, for example, to help build planes and help build cars.
Very cool. Do you ever miss, the dream of maybe going to space or anything like that?
Well, my wonderful colleague, a student with me from undergrad at MIT, and then faculty with me for a while at MIT AeroAstro, Woody Hoberg, he's actually on the International Space Station as we speak
awesome.
right now.
Cool. So you still have friends in the space industry. And if things continue moving at the pace that they have recently with the Commercial Crew Program and SpaceX, I'm sure that, the work in robotics will definitely boil over to aeronautics again soon.
Well, it's an incredibly exciting time in aerospace for that reason. The deputy administrator of NASA just recently came through MIT and our department. And one of the key areas she highlighted as being critical and a major investment area was specifically human-robot collaboration for sustained presence on the lunar surface and beyond. So
that's music to your
everything
ears.
We're doing here in factories and on Earth, that's going to translate. We're going to make it possible there.
Very cool. Well, thank you for that background. Ben, I'm going to ask you the same question. Would you please tell me how you discovered your passion for robotics?
I think in some ways I'm still looking for my passion for robotics. I visit Julie's lab and it's very cool, but I didn't start, my path is very different from Julie's, where I was not a science enthusiast or a robot enthusiast growing up. Instead, when I would read science fiction, I'd be really interested, but I'd be interested in the politics and the opportunities for corruption and how the new science and innovation would translate into prosperity for some, and then difficulties for others. So I came to study robots through a much different direction. It was a focus on communities like the ones near where I grew up that were struggling with the decline of manufacturing. And these were places that really had lost their middle class. They didn't seem to have a direction. They're losing population. And, I would drive by as a kid, factories with windows blown out. And these places seemed like really like they did something really significant historically. And I didn't really know what that was. So as a graduate student and in my current role, part of what I look at is how the decline of manufacturing in the US, but also around the world, has shaped communities, and then what opportunities there might be to rebuild some of the prosperity and the middle class, the job opportunities for people without a college degree that really thrived before I was born, 50, 60 years ago. So that brought me, I think, in a roundabout way to study automation, because although for the last 5, 10 years, there's been a narrative that automation is bad for workers, the conclusion that I've come to, and I think that Julie might agree, is that automation is really the only hope for workers in high wage contexts, because we see that when new technologies are deployed, wages can go up. There's opportunity for higher skilled work, and there's opportunities to compete for advanced industrial countries like the United States. So that's I really started with more the social dynamics, the community challenges, and then arrived at robots maybe from the opposite direction from what Julie did.
Very cool. It sounds like you would have had a career as a novelist, if not a social scientist, for a little while there.
I'm not sure as a novelist, Chris, but these funny forks in the road. I arrived at MIT as a PhD student. I had worked in Silicon Valley and was frustrated with a lot of high tech startups and the business practices they were using, and I wanted to get out of it. So I came to MIT to study economic development in sub-Saharan Africa and the role of taxation in developing countries. And then my advisor, right as I was arriving, left to go to UCLA. So I had this choice: maybe I could follow him or try to continue this path, or just totally chart a new direction in my first year of graduate school. And that's what I did.
Yeah, to your point about humans and robots actually working side by side, I'm aware of the International Federation of Robotics yearly puts out a report, and they tend to see a lower unemployment level associated with more robot installs. It's not like installing more robots equates to more unemployment. It's actually the opposite of that. What made you want to deep dive into the field of industrial automation, Julie?
Well, I did my PhD at MIT, and will be, completely honest. For those that are following the grad trajectory, I was on an NSF fellowship where I got to do whatever I want, totally decoupled from any real applications. And what I wanted to do was develop intelligent robot teammate and partners. So that's what I did my PhD on. And as I was finishing up, I was applying for faculty positions. I was applying broadly as well, the positions in industry at NASA. But as I was applying for faculty positions, the timing was right, where there was a lot of interest and investment at that point in moving a lot of the state-of-the-art technology and autonomous systems into the real world, but with an increased understanding that you can't truly replace all of what a human does in many of these contexts. So the challenge is reframed, and the challenge becomes, how do you architect your problem framing for your AI or for your robot system to be able to work with messy humans, humans that add uncertainty and variability in many different ways, in cognitive work and in physical work. And one area where this was, particularly present, these challenges, was actually out at Boeing in manufacture and assembly of large commercial airplanes. And so I received the faculty offer from MIT, and contingent on that offer was to go away for a year out to industry and to understand the deployment of real technologies and how you make the business case for those technologies, and the state of the art. And so I spent a year on the factory floor, in
Programming robots and deploying automation. Yeah.
in Everett. Yeah.
Cool.
Working in robotics and automation for assembly of large commercial airplanes. And I have to tell you, it was like one of the most inspiring experiences of my life to see like a beehive of people. Like you think it should be done, manually, but it's a beehive of people building up these incredibly complex systems, and a lot of opportunity to make that work better and more productive and more ergonomic, but nothing but challenges in the integration of those capabilities with the human work, which can't. There's a reason people are doing many aspects of those jobs and will need to do them for quite a while. And from then on, I was hooked in manufacturing and assembly, and have been working on it ever since in aerospace and automotive, and most recently with Ben with a focus on small and medium enterprises.
Very cool. Yeah, Boeing, there's a lot of hand work there. There's a lot of artistry and artisan work that goes into building aircraft and really any manufactured piece. I think people think that you can just do lights out, no problem. And that was actually a recurring theme in your article. I noticed between the GM example and the Tesla Model 3 rollout, there was quite a few places where lights out, you have this amazing picture in your head of automation, and that we can just have robots running autonomously everywhere, but really the human factor is important. So, Ben, in your research, you found that a lot of automation products don't deliver the expected results. Why is that?
Well, I think there are a few challenges. So, just to step back a little bit, I think one of the Julie talked about her moment of inspiration at Boeing. I think there's a similar moment, a kind of aha moment for me in thinking about out of the Great Recession, the United States started to realize that the decline of manufacturing capabilities was a real problem, and that we needed to somehow start to rebuild. And one of the big investments, a $1 billion investment, was in manufacturing innovation institutes, where there was, a robotics institute in Pittsburgh, an additive manufacturing institute, ARM, an additive manufacturing institute in Youngstown, and a network of these institutes all over. And the emphasis really was, how do we push our technology leadership in these different areas of equipment technologies, really, or materials technologies that enable manufacturing. But one of the real missing pieces in that model was driving adoption, because while ARM is wonderful as a way of facilitating advances in robotic technologies, it was at the time, less than 10% of manufacturers had any robots at all. So they're driving these technologies that are really only used in a narrow segment of the market. And this kind of brings us to your question, which is, why is that? Given what we know about what happens when firms do adopt these technologies, they end up hiring more people, they become more productive and competitive. Why is it so rare? And this is a puzzle that's motivated us a lot. I think that there are a couple reasons. One is the design of the technologies, right? So oftentimes these technologies are designed with a very steep learning curve and a lot of barriers to entry, such that many firms don't have the skills or the resources to take a risk on going and integrating a big robotic cell. These aren't the cells, the robots that Julie, robotic applications Julie works on, or that UR does. But historical model of a robot is you have this caged installation that is, high six figure investment.
We all remember those commercials from Ford of those, monolithic plants, huge robots swooping into weld cars. That was the vision painted in like the mid 2000s of sort. Yes,
for sure. And I think in some contexts, that's still what robotics looks like.
Yes.
And for a lot of firms, it's unsurprising that they look at that and they say, oh, great for you, but that's not for me. I'd rather have the flexibility of my workforce that has lots of skills, that's been with me for decades. And if I am going to make a new investment in capital equipment, it's going to be that next CNC machine. It's not going to be automating the process. So that's one piece of it. And then another piece of it, which I think we'll get into with what Julie and I have been writing about, is how success is measured in terms of robot adoption. So historically, this applies in robots. It also applies in automation software. A lot of firms measure success as, can the robot do the task more productively than a human? So is the robot going to be do more of the tasks, more of this repetitive task in a day than a human would? And then what would be the cost comparison over time? And comparing the performance of a robot as kind of a more, is the robot a more productive human at this task, is really a false dichotomy, because the robot is going to miss a lot of the added value that a human, which can observe the process, can make improvements to it, is far more flexible, far more creative. So that comparison we look at is really false and limiting. So what we want to refocus our attention on, like redefine success as, can the robot be a productive member of the team? Can the team, human workers and robots, be more productive as a unit, instead of just, can the robot outcompete the human?
Yeah, it's very interesting. Yeah, I mean, just for context for the listeners, the classical ROI, or return on investment calculation, is essentially imagining that you could replace a human laborer, and you would take their hourly rate, the hours throughout the year, multiply by maybe the shifts that they're going to be running. And if the robot can replace that worker, then you have that as the ROI. And it's very simple and it's one dimensional. And I think, Ben, your work points to that. There's a lot more factors to take into account in that area. So what else, how do people put a number behind those unquantifiables,
And
those
Chris,
hard things?
just to underline what you just said, what's so interesting is that when you see that calculation, but then you go to factories that have deployed robots, it's not like they have fewer people around, right? Maybe they have one person to operate more pieces of equipment, but you still need the person to fine tune the process and participate in it. So I think that's one of the challenges of that ROI calculation, is that factories that do it are going to be disappointed, because a person's still going to be necessary to intervene. It's not going to be a set it and forget it or a lights out
Yes.
for many companies, particularly SMEs. But I think
Yeah,
Julie
it's a
might
little
have other ideas
disingenuous.
about how to calculate this.
Yeah, that's awesome. Yeah, Julie, what do you have to say about this topic?
Yeah. Well, I mean, it raises the question of, what is the value of, a person, and how you're sort of thinking of their role within the work that's changing as you introduce a robot. And as a part of MIT's task force on the work of the future, which was the precursor and sort of starting to the work of the future initiative that Ben and I now lead. My students, as well as social scientists, and I had this incredible opportunity to conduct site visits and interviews around the world, looking at the adoption and rollout of a constellation of Industry 4.0 advanced technologies. And one of the questions that the team asked was, for these, these particular companies or entities that were kind of ahead of the curve, it's like, where is this all going? Is this headed to a lights out factory for you? And there were a variety of responses to that. Like, some people did say, yes, our goal is a lights out factory. But the surprisingly substantial portion said no, that wasn't their goal. And in one of the quotes from one of those interviews, the person who was leading the tour, when asked this question, he stopped and he turned around and he said, a lights out factory. Why would I want a lights out factory? A factory without people is a factory that's not innovating. And, that's, when you look at, the value of people in this process, in my own work in deploying systems on automotive lines, I remember being on the factory floor and seeing some associates on the edge of the line slowly disassembling and reassembling a car. And I was like, what are they doing over there? And they said, oh, we pull them off the line so they can innovate our assembly process. And they were like installing, and then they were like scratching their heads, and they were like talking to one another, and they were kind of like pointing. When you look at improvements in assembly processes and those very well characterized kind of learning curves for automotive or for aerospace or for other sectors, those are human driven. And so when you think about, programming, installing a robot, and in advance, and then just leaving it, like, you don't have any innovation, you don't have any improvement, and it's really impossible
Sure.
to optimize that process, a priori when you're just setting out. I think what's incredibly exciting about these firms where everything is really working and they're scaling robots is when we've had the opportunity to talk to the operators, we say like, I remember Ben asking in one particular place, like, how has your role changed since, circa a year when this robot was introduced? And he said, oh, I used to be crazy busy. I was just like feeding all these machines and running back and forth. And it was, it was like very busy. And now I oversee all of these machines, not just, those few that I was feeding. And I now have 20% of my time to look at all this and think about how to make it better.
To innovate.
To innovate. So in sort of physical work and sort of like, leveraging someone's cognitive ability at that level, introduction of the robot supported that, and the sort of positive feedback loop for the firm to be able to further innovate and improve. And so that's really the success story and the goal. And from my perspective in developing technologies, then the question becomes like, now our new problem statement is, how do you develop technologies that support those with the domain expertise to be able to be engaged and innovate in the use of that technology and the reprogramming of it and the redeployment of it? I think there's incredible opportunity here.
Yeah. In your Harvard Business Review article, you mentioned two kind of standout stories that jumped out to me. The GM article, which kind of like was the intro and almost the outro for the article, talking about how they failed with lights out automation in the 80s. And then I think a much more probably popular, well-known story, at least for me, I follow it. It was Tesla in 2017 with the Model 3 rollout when they tried to just automate everything in the factory. And I did a little research, and Elon Musk does have 5 rules, I think, coming out of that 2017 fiasco where they nearly went bankrupt. And those 5 rules end with the last one being automation. So the first one is make your requirements less dumb. The second one is delete the part or process if you can. The third one is simplify and optimize at that point. The fourth one is then work on your cycle time, and only after that do you look at automation, in his opinion, at least. And I think the overarching theme for that is that, a lot of people don't understand their processes, or they're not even given enough time to think about the innovation on their own processes because they're just doing their work every single day. And so I think to your point, there's a lot of, reflection that has to be done, and an incremental automation where you can start to get people more of their time back to think and innovate is really the key to better adoption. I don't know. I'd love to hear your thoughts on that too, Ben.
Yeah, the rise of lean in the late 80s and early 90s led to a bunch of research on a very similar question, which was, as a bunch of companies adopt new CNC equipment, as well as these new strategies for production, right? New kind of process parameters that were low waste, the Kaizen system. What was the combination of technology and operational strategy that worked best? And what these studies found in the early and mid 90s, particularly focused on auto, was that companies that adopted new technology saw the biggest benefits from those technologies when they reorganized the processes as well as the workforce to support those new technologies. So the lesson, which might seem obvious today, was you can't just take a new technology and bolt it onto an old process.
Yeah, just throw it.
You need to use it as this opportunity to restructure how you think about your production in the first place, and that's really hard, and it's risky in some cases because you're venturing into an unknown, and it's not surprising that larger companies are better able to do this. They have larger engineering teams. In some cases, they may have R&D units that can handle this process. But to do this as a small company where you're trying to keep up with orders, you might even be behind on orders. We really can't have high expectations for these companies to invest in restructuring their processes from scratch, which is why some aspects of lean, like continuous improvement, have caught on a lot at small firms. But total reorganization, like what Tesla has gone through multiple times now, is far less practical. I think there's a lot of, even though, I think we might give Tesla a bit of a bad rap in the article, there's a lot to learn from what they've done in standing up automotive factories much faster than their competitors. So I think, part of the subtext there is that even Tesla, which has thrived in as a
continuous
software company,
improvement,
they still struggled with this. So we would expect that if anyone would thrive in a lights out context, it might be Tesla, but even they have had a difficult time.
Yeah, very cool. Very cool. So I'm going to give you a hypothetical. I'm going to pose this to both of you. Say I'm the factory manager in a medium-sized company. We have around 100 people in our production and a lot of manual processes. So there should be potential for increased output and improved working conditions for my employees with automation. What would I do to reap the benefits and avoid the common mistakes?
This goes back to what we mean by positive sum automation. So historically, the factory manager with 100 people might look at automation or adopting a robot as an opportunity to increase productivity. And the way that you identify where you can increase productivity is, okay, what's a repeatable high throughput process? Where do I have a high volume and a low mix of production? And that would be where there's an opportunity for automation. But that's really limiting, because for a lot of companies, that process might change often, and that would require a lot of resources to change an otherwise rigid automated system. So what we mean by positive automation are tools that can allow factory owners like the one you mentioned to increase productivity while also maintaining or even increasing their flexibility. So being able to introduce automation in higher mix, lower volume contexts. And what that requires is easier access to programming and reprogramming the tool, so lowering switching costs, and also more involvement of the workers on the line, the domain experts along the way. So to get to your question, like how do you reap the benefits and avoid the mistakes? I think one of the key principles is what we would think of as a bottom-up deployment of automation, of including the people on your floor who know the process the best in understanding how the automated system works, what it looks like when it's working well, and what it looks like when you're not actually capturing all the value. So what we've seen in a lot of contexts is, in some cases, engineers if there is an engineering team at the firm, working together with production workers who would be overseeing the system, and also production workers going to places like you are to get a boot camp on how to deploy and program and reprogram a robot to make it most effective and integrate it within an existing process. But Julie, I know you've seen a lot of this in the field too.
Yeah.
It's like instead of having that transcription layer of, trying to have an integrator or an automation engineer come in and redesign the process, it's about putting the domain expertise and the control in the hands of the same person, the person who's there on the line doing it, right? Is that kind of the gist of it, Julie?
Yeah. To underscore Ben's point, many of the successful applications that we've seen follow this human-centered approach that is really putting at the center of that the domain expertise of the person that understands the process. And so at a large firm, the way you see, and even large firms are not uniformly successful, right? So even looking at the large firms, it's those that are putting the engineers side by side with the domain experts on the shop floor that are seeing the greatest value out of integrating and deploying the new technology. And so in small and medium firms, this requires an investment and a willingness, and almost these types of like what Ben calls, kind of these entrepreneurs that are willing to, step out of the more traditional role in their job, and then support at the firm level for bringing in sort of a new skill set around working with the technology, and also more deeply understanding its limitations and its potential sort of benefits that can be brought to bear on the process that they're thinking about redesigning or re-engineering.
Yeah, and one of the challenges, and just to build on what Julie you're saying, and one thing I think we both noticed is that a lot of the factories that we visit are extremely good at what they do. They have very low scrap rate. They are committed to continuous improvement. There are lots of skills on the floor, and they've just become expert at what they do. But one of the challenges of deploying new technology, of being a shop floor entrepreneur, is that you have to fail before you succeed, right? And that's like one of the most popular characteristics of an entrepreneur is being okay with failure and being resilient in the face of failure. But
Yes.
in manufacturing, companies aren't set up to fail because your whole optimization function is to minimize scrap and try to keep up with orders. So the big challenge, like how do you reap the benefits and avoid the mistakes in automation, is give yourself opportunities to fail and give yourself the time to figure out what a good deployment would look like. Because I think that the first instinct might be, hey, I tried this robot, it didn't work, now it's off in the corner, it's not for me. If
Yes.
that's the first instinct, it might be, well, I tried it and it failed, but now I need to experiment with it in other ways or with other functions. It's not that it just is totally irrelevant.
Yeah, I see that. A lot of manufacturers are chasing nines and they don't give themselves a lot of opportunity to fail. Definitely. So, Julie, you talk a lot about switching costs. That was something I saw in the article. We mentioned it today quite a bit. And it seems like the switching costs are relatively like centered around human labor versus robotic. And what is the cost of switching between the two? So can you just expand on that in the context of this concept of positive sum automation? How do you reap the benefits there? And what are the switching costs that a manufacturer would need to take into account in our hypothetical situation, 100-person small business? What do they need to be looking out for?
Yeah. Well, even as we're talking about, needing to have, room to be able to fail, you might think like maybe that's a natural part of the process for someone who hasn't worked with these technologies before. But, the secret is that in the robotics lab at MIT with the PhD experts from around the world trying to make these systems work, it's the dirty secret is that it is very, very hard to make a robot do anything. The programming costs associated with the system are significant, even for deep experts in the technology. If you're looking to embed machine learning into that system, God forbid, then you have the whole data collection and cultivation process associated with that. And so when you even leaving that aside, if you look at sort of the overall cost of deploying a system, like the hardware itself is a very, very small fraction for a firm, or even just you think about, in the research that we do in our lab, we buy the robot, but that's a very small fraction of the overall investment that's required to make this technology useful in a task or an application. And it might be 3 times the cost of the hardware. It might be 10 times the cost of the hardware. So it's very, very significant. And it takes expertise to program the system. So, for a smaller firm working with a third party to reprogram that system, it really just becomes prohibitive. And the gotcha is that the high mix, low volume setting is one in which you may need to or want to reprogram that system more frequently.
All the time.
And of course, you desire the ability in-house to be able to do that so that your domain expert can innovate in the process and innovate in how you're using the technology. So the traditional trade is that you have to give a lot up in flexibility to gain other types of benefits and productivity or quality or other traditional
cycle time
metrics. Yeah. So when we talk about positive sum automation, this is looking at how we gain those benefits sort of on the traditional metrics, but actually with increased flexibility provided to a firm in deployment of that technology and implementation of that technology. And so there's aspects in sort of the development of that technology, which is what I work on in the laboratory at MIT. But there's also in choices you make in procurement of systems that support sort of low code methods for working with these systems. There's implementation choices that you make in terms of how you decide either to work with a third party, and there could be very good rational reasons for doing that, or through a longer process, building up in-house expertise to be able to work with the system. And maybe that's a hybrid strategy, right? It's not really an either or. I remember from one of our visits, our host at a firm said, this is about. I think he had worked with third parties quite a lot, and with some of the systems he had implemented in his firm. And he said, now this is about learning how to fish instead of being given the fish, and was actually taking a machinist and giving him a very long runway. Like I think he said he was going to give his machinist like a year or a year and a half to learn how to program a UR actually. And he did it in much less time, which is a great success story. But that's
awesome.
An investment in being able to bring that capability in-house.
I'm aware of one customer called Derek's. They're out. I think Ben, you mentioned that you're from the Midwest, and they're from Oregon. They're kind of a small, medium-sized manufacturer, and they actually they bought a UR. They had everyone take an online academy, but then they created a competition to find out what operator on the line would like to be the robot supervisor. They had a little programming competition. A woman ended up winning. It became her new job. She loved it. They started actually using it in recruiting ads and saw that they were hiring on better and talent more often as a result of all this stuff. So I think empowering that operator to kind of step up and do that was a really cool story.
That's great.
Yeah. All right. Well, we are running out of time here, so I'm going to ask just a few more questions. We're going to go to our rapid fire here in just a moment. But before we do, I'd like to ask a forward-looking question to Julie. How do you see the future of robotics developing?
So I see multiple possible futures. So, and this is supported by all of the wonderful research that Ben and the other scholars and the social scientists in social sciences. Anyway, let me redo that.
Okay. Yeah, no worries. Let me ask it again.
Yeah.
So let's ask a forward-looking question to wrap up here before our rapid fire questions. How do you see the future of robotics developing, Julie?
Yeah, I see many possible futures. So this is not a situation in which we have a new technology and it's just going to have, a set of impacts on society, a set of ways it supplants or makes jobs better or worse. But the data supports that, as you bring in these new technologies, there are many possible futures. There are futures in which firms become more productive or they don't see the benefit in productivity from bringing in the new technologies. You see examples in which firms have higher wages, actually more employees, and then you see maybe composition changes, maybe more workers overall, but fewer middle managers. And then you do see examples where it's like the lose, lose, lose. Like maybe they don't see gains in productivity, maybe they don't see benefits for their workers. Maybe they don't see increases in jobs, but the technology is actually supplanting. Maybe it's making jobs worse. You actually see all these possible outcomes. So the question becomes, what are the decisions we make that reliably can move us to the win-win-win of these futures, which is increased competitiveness for firms, increased higher quality jobs for workers, and more jobs overall. And this is important, maybe in a context in which there's 700,000 openings in manufacturing. Maybe the goal isn't necessarily to create more jobs, but many of these firms can take on more work, but they lack the workers to be able to do it. So how do we augment their ability to do that through these technologies? And there's decisions that we see around design, around how firms sort of organize and implement the technology, and then how they make the business case for these technologies that we believe can move firms in a direction that more reliably realizes these variety of positive outcomes. So in terms of what we see going forward in robotics, I see like strategic investment in the types of technologies that enable the acceleration and adoption of robots that lead to these positive outcomes is really the focus. And these are the types of technologies we develop in the lab and are actively working to bring to those outside of the lab to help realize that future.
Very cool. I look forward to seeing more of your work in the future soon. It sounds like you're Dr. Strange. You see many futures, but it sounds like positive sum is definitely one of them if we can bring the technology and the societal influence together to really drive it. So let's move to some rapid fire questions. I'm going to start with Ben here. What's the most interesting robot application you have ever seen?
I've seen far fewer than Julie, but just to give Julie a shout out, she and her lab have a robot installation in the MIT Museum, which is very cool. It
Cool.
does things from making sandwiches to setting a dinner table with
Wow.
participation from museum goers. So if you could check that out, that's I think very cool robot
I love that.
application.
Close to home. Cool. And Julie,
Yes.
what's the most interesting robot application you have ever seen?
Oh my gosh, they're all interesting. How can you choose? How can you choose? Um, the I get really excited. A lot again, like going to production environments, which I just love. But there's also the NASA robots. There's so many cool systems out
Yes.
there. There's Boston Dynamics. There's
Yes.
the new Wow video that comes out from them every so often. But thinking about production environments, there's actually relatively few of the collaborative robots that are truly used in this kind of like responsive collaboration way. A lot of leverage around being able to remove the cage, being able to flexibly use the factory footprint, put it right next to people, and a lot of benefit from that. But relatively fewer applications where there's true interdependence between the work of the person and the robot. And I was on the assembly line for a firm that assembles high performance scientific equipment. And just totally casually, they were like, and here is how we use our UR to support the operator in assembling this, like, very, very delicate, sensor. And then the UI was like, choo, 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 and the person, they were just like in perfect
Cool.
choreography and sync. And it
Yeah.
was beautiful. It was
Like,
beautiful.
this is what I
And
want. Yes.
I was like, why do you need me? You're living the dream. But
That
then
sounds
they
like
were
they had
like,
some
oh no,
talented
no.
people.
Yeah, yeah,
Yeah.
yeah. It was really cool. It was really cool. But then, the flip side is they were like, oh, but the person actually has to fit to the choreography of the robot. Like a person and robot can converge in that way. And you can see all these benefits, like ergonomically and, in terms of productivity and in terms of quality. But the person still had to do like the minor adjustments to like fit to the pre-choreographed movements
Hmm.
of the UR. And I
Hmm.
said, actually, like half our workers like won't work with it
Yeah.
because they feel like they have to kind of fit and adjust to the robot rather than the robot adjusting to them. And this is an example where personalization and being able to learn
Yes.
the workflow of an individual, these sort of individual differences become really important. But having that be something just like that's in use every day, like that's the future.
That's
That's
cool.
so exciting.
Yeah, you mentioned in the article in overhead robot assembly, and the workers didn't love using it because they had to use the prescribed order of operations, and it made me think of kind of like just a basic state machine in some ways. I try and recommend people to program robots in such a way that you can kind of do any of the tasks at any time depending on an input. But I think seeing how that actually, like, typically they use a PLC to get to command that, right? But like putting that in the hands of the operator and allowing the operator to do local optimization for their task at that level, that's really cool. That was also the longest rapid fire question I've ever had, but
Sorry.
that's okay. It's okay. Let's keep moving. So Ben, you're up again. If you could automate anything, what would you automate first?
Yeah, the most dangerous jobs. So a lot of the big lesson out of the pandemic was meatpacking industry jobs that were very dangerous, a lot of exploitation, and there's been a push to automate some of those, some of the worst jobs. There are potential, long-term implications of automating that type of work, but with the right implementation, I think that could hopefully create better job opportunities for the populations that would be affected. Again, you're asking rapid fire questions, but I
Yeah,
feel like they're so deep, they're so rich. It's like you're
they're
asking,
deep. I
a
like it.
robotics engineer about the best robot application. We could talk about that for a long time.
Yeah, we talk about the dull, dirty, and dangerous jobs as pretty automatable. So, sorry, Julia. Same question to you. If you could automate anything, what would you automate first?
I would ask the person doing the work what they think should be automated
Aha.
first, and
Good
start
answer.
from there.
Good answer. Yes, put it in the hands of the operator. Okay, final one. Who would you love to hear on this show in the future, Ben?
Well, Julie just totally had the right answer to the what to automate. So maybe we could have operators who have been affected by automation on the show in the future to talk
I
about
love
their
that.
experience in the spirit of kind of stud circle and talking to people who are doing the work.
That's a great idea. And Julie, what do you think? Who would you love to hear on the show in the future?
I love that. I second that idea.
Cool.
Yeah.
All right. Finally, conclusion. Where can we go to follow you and your work, Julie?
I don't know. But you're gonna have to edit this out. I'm gonna.
The MIT Museum, I think, or
Yes, that's a great idea. Let me answer
Yeah.
with that. Ask the question again.
yes,
Or they could write. You could write to us, and we could
Yeah.
follow up personally from there.
Okay, that sounds good. Thank you, guys. All right, that is all for today. Thank you, Ben Armstrong and Julie Shaw, for joining us on episode 1 of Reautomated, the podcast, Positive Sum Automation. If you have not read their article titled A Smarter Strategy for Using Robots in the Harvard Business Review, please go out and read it. It is awesome, full of tidbits. I wish we could have done this for longer. I could have easily talked to you guys for 2 hours. So we'll have to have you on again in person. Perhaps I can come over to MIT and do it live next time.
Awesome.
Thank you
Great.
for joining me.
Thanks, Chris.
Thank you. See you.